All right, so here we go with a lesson on exponential versus linear functions. So a comparison between the one that we know a lot about, linear functions, and the one that we just learned about. And so I do this because it really kind of solidifies what you know and how you can apply it to the other, to the exponential, the new one. So by the end of class, you'll be able to know the difference between a linear and an exponential model, and you'll be able to write an exponential function given 2 points. Okay, so just from 2 points, you'll be able to write both. Now let's not forget that the exponential model is that new one, that new equation, y equals a times b to the x power, and the old guy, the grandpa of all this, the grandma you could say, the linear function, the y equals mx plus b. Now there are some similarities and there are some differences. The most obvious similarity when you look at them, they both have y and x, and the reason is they're just going to give you an input and an output, a point on a graph that is two-dimensional that you can plot. Okay, so let's not forget, this is all about just graphing either a line or an exponential function. In addition to that, they both indicate a y-intercept or an initial value. So in their equation, they'll tell you where the starting amount is. Okay, and they both indicate whether the function increases or decreases. Now let's remember, when the slope is positive, it rises and goes up. But when the slope is negative, it comes down as it goes to the right. When we have an exponential function, if it's greater than 1, the b value is bigger than 1 from the last practice, we saw it growing because it's multiplying by a number that's bigger than 1. But as soon as we multiply by a number that was less than 1, still greater than 0, it made it smaller, like multiplying by a half or a quarter or maybe an eighth. All right? So those are the similarities. How about the differences? The differences are a linear function adds every time. So it's a constant amount in which we are adding the same amount. And the exponential function is all about multiplying. Now it multiplies by the same amount, but it does not use addition like the other one does. It multiplies. Please pause the video if you are watching this as a recording. And let's talk about the linear versus exponential model once again, and this time in terms of a table. Okay, so one table is a linear function, another table is an exponential function, and we want to try to figure out which is which. Well, the x values here, we kept it simple. They only go by ones, so don't worry about those. Let's take a look at the outputs, the y values. I'm going to try to stay consistent to what you maybe did last year in 8th grade, where the teacher would make little triangles, right? They'd come on down to the chart and they'd say, okay, find the amount of increase or decrease. So we're going to stay consistent with that. So in the first one, we can see that we go from 5 to 10, 10 to 20, 20 to 40, and 40 to 80. So we're not increasing by the same amount. One is an increase of 5, then 10, then 20, then 80. But we could say that we're multiplying by the same amount. So times 2, and times 2. And so because of that, this is the exponential model. Because B/C, I like to keep things short and sweet, it multiplies by 2 to increase. It's larger than 1. Now over on the other side, we can see this kind of like we saw last year, where it's 8 to 11, 11 to 14, 14 to 17, then 20. We're just adding 3. So because this is an addition, we would use this as a linear model. All right, so this would be linear because it adds by 3 to increase. Well, but haven't heard from anybody yet. So we can move on. Table number 1, table number 2, same 2 tables, but this time we want to write the entire equation. Now, a part of that equation is going to be how much we're multiplying by. So let's put that back down. Multiplied by 2, and over here we added by 3. Now we've already determined that this one's the exponential model, so y equals a, we could do parenthesis b x, and the linear model is y equals mx plus b. Now, let's put in what we already know. We already know that it's being multiplied by 2. So that means in parentheses, I put the 2. I always raise it to the x power. That one's done. Over here, it was adding 3. So I put this in for the slope, and I always write it as 3x. Now, the next part of this is trying to find the y-intercept, and this can be found very easily as long as you identify where 0 is for x, right? So here's my 0, so that means 0 left or right. That means you just go up 5, so it's the a value when it's an exponential. So a little confusing there that they have a different letter, but yes, 5 is your a value for that equation. And over here, again, identify where it's 0. Now this is your y-intercept. It's a b because it's linear, and you just put this at the end as plus 8. And there you have it. You've just written a linear and an exponential model from a table. An exponential on the information of just 2 points. All right, just 2 values, a 0, 12 and a 1, 3. So we're going to create a linear equation that passes through those 2 points, and we're going to create an exponential. Now, based on what we just talked about with y-intercept can be found when the x value is 0. So right here, this is your y-intercept. Because when I plot this, I go 0 left or right, and I just go up 12 to put my point right on the y-axis, okay? Now, from there, we need to be able to come up with a linear equation that passes through the 2 points, and we got to come up with the m and the b. Well, we just got the b because that's the y-intercept. b equals 12. But I got to come up with the slope. Now, this might be a little bit more difficult to remember because we did it so long ago. In a normal school year, these lessons are much closer together. But to find the slope, remember that y2 minus y1, x2 minus x1 formula? Yeah, so that's how we're going to find the slope between 2 points. Again, these come always as an ordered pair, alphabetical order, x and y. Here's the first point, here's the second point. From there, you plug them into the formula. So it is 3 minus 12 and 1 minus 0. That's going to give me a negative 9. 1 minus 0 is 1. How about we call it negative 9? So now we've got the m, we've got the b, we got the whole equation. So right up here, y equals, how about negative 9x plus b? Identify the a value, because again, the a value is the y-intercept, and if we're using the same 2 points, that's not going to change. Now we need to come up with the b value. This is our first time doing this, so pay close attention. To find the b value, it's not this fancy formula with subtraction, it's actually just y2 divided by y1. So remember that. All right, so to find the b value, just divide the two numbers, because dividing undoes multiplication. It ends up telling you what you multiplied by. Now the y2 value is still 3 and the y1 value is still 12. So reduce this to make it a little bit smaller fraction. How about 1/4? Let's put it all together as y equals y-intercept a value first, then the 1/4 to the x power. Inequalities. Now don't make these any more than they are. They're just telling you how much of the screen they want to show. So for the x values, from -2 to 2, and for the y values, -5 all the way up to 15. Now, if we already have 2 points, we've got the y-intercept that we plotted, and we've got the 1, 3. So we know that they're going through both of those, but we really don't know how they look. So the graphing calculator will certainly help us with that. I'm going to use the TI-84 Texas Instrument calculator to demonstrate this, the one that you had the option of picking up at the beginning of the year and also purchasing. So I want to keep showing you this if you spent all that money on it. Go ahead, press y equals. Enter the two equations exactly as you see them. Got to use the negative key, which is under the 3, then 9. If you do use the subtraction key, that will make it incorrect. It'll give you a graphing error. follow it up by x, and then add the y-intercept at 12. Scroll on down, hit the down arrow, enter the next one, again exactly as you see it. The y-intercept goes first, then parenthesis to show multiplication. To do the fraction, just do 1 divided by 4 to make a fraction, close it on out, and then raise it up to the x power. Now, if that was too fast, standard 10 by 10 by 10. It's just 10 to the left, 10 to the right, 10 up, 10 down. I want to change this so that it's 3 to the left, so -3, and then 3 to the right. So 3 to the left of 0, 3 to the right of 0. I want it to go by ones, and then they told us to go by to go from -5 for the y min, so down 5, and then all the way up to 15. So 1, 5. So you change your window to make the graph look a little bit differently, because what you're going to see is the difference between a straight line, a linear function, and a curved line, the exponential function. So there they are. All right. From here, we just want to take that picture and sketch a graph. Again, our classic linear function is a straight line between these 2 points. And the exponential, which you're getting a little bit more comfortable with, is a curved line, and it doesn't go below the x-axis. So it, again, hovers right above. All right, looks like some people are helping each other out, so that's great. Any other questions, please? So we've got an exponential function. We know its equation. We want to find the average rate of change, the ROC we've called it. So again, that can be found by using the y2 minus y1 x2 minus x1 formula. And we have not nearly used this equation or this formula as much as maybe we would have done in previous years. But this compound inequality is not fancy. It just means use these 2 numbers. Use the one with x of 0 and with x1. So these would be labeled x and x, y and y, where this is the first one, this is the second one. So written a little bit differently than as they come to you in a point form. All right. From here, do 8 minus 4, y2 minus y1, and 1 minus 0. And so once you subtract the top, subtract the bottom, it ends up being 4 over 1, which, yeah, is just plain old 4. Okay? I'm going to switch my color real quick, and that will hopefully help us distinguish between the next one and the one we just did. So this time, the compound inequality says between 1 and 2. So we use these values, these 4 numbers, where I'm not going to write the formula again, but we do the y2 minus the y1, and the x2 minus the x1. 16 minus 8 is 8, 2 minus 1 is 1, so it ends up, again, as 8 over 1, which we don't really need to write. We can just write the 8. And then finally, we finish up with 2 to 3. So another color here, so that we're going to go from 2 to 3. So the y values for this would be 32 to 16 and 3 to 2. Subtract the tops, subtract the bottoms, you're going to end up at 16. ROC, back when we learned about it, the ROC is being multiplied by 2. And it's just trying to show you that it's not a constant rate of change. All right. We're going to finish up with one more and the use of a calculator. But this one's a little bit more straightforward because it gives me the equations. So this equation is y equals 2x plus 5. And the other equation, which we're hiding behind our box here, is 2x 5 times 2 to the x power. So let's get the calculator out and plug these in. So your linear function overtakes the exponential function, and right after that point where they meet, it's sayonara. That exponential function is going to continue to grow because it uses multiplication and not addition. All right.